Hey, what's up? It's your old pal, Mr. Cook, and we are working on the Algebra 2 practice final. It's a multiple choice version of the final exam review. I'm just going to go through this page by page, so we're going to do the next 5 problems. So this one says to write an equation in the form y equals a times parentheses x minus h squared plus k for the parabola that has a vertex of that and passes through that point. Well, the way that we can do this is whenever we're given a vertex, that gives us the h and the k value for this. So we just write those up there, h and k. And if we plug those in, the equation looks like this so far. Y equals a times parentheses x minus 2 squared plus 3. And if you look, there's only one of them that looks like that so far. So B would be our answer. But I'll show you how to get the rest of it, that little 3 right there. Well, because this is what you're supposed to do, if the problem wasn't done at that point. You take the 0, that's the x value, and the 15, that's the y value for some random coordinate. And you put those numbers also into the formula. So 15 is y. It equals a times x, which is 0, minus 2 squared plus 3. And then just finish solving it. 0 minus 2 is negative 2. Negative 2 squared is 4, so that's 4a plus 3 equals 15. And then solve for a. If I subtract 3 from both sides, I get 12 equals 4a. And if I divide both sides by 4, I get a equals 3. See, so that's how I get that 3 right there. So that's how you can complete one of these problems. The next one that we have is, given the parent function y equals x squared, what are the transformations that are needed what transformations are needed to graph this to turn into that? Well, this just, the way that you get it is, the numbers that are inside the parentheses with the x tell you that the graph is either moving to the left or to the right. The numbers that are adding outside the parentheses tell you if the graph is moving up or down. And if the number is adding, it's moving to the left. If it's subtracting, it's moving to the right. If the number is adding out here, it's moving up. If it's subtracting out here, it's moving down. So the graph is moving to the left because it's positive 3. And it's moving up because it's positive 2. So left 3, up 2, that's A. A would be our answer there. Next one, find the x-coordinates of the intersections of the parabola and the line. Well, one thing you can do is if you have a graphing calculator, you can just graph them out. So if I graph it out, x squared plus 7x, and then the second graph would be 2x plus 6. And I hit the graph button. There's the parabola. There's the line. And let's see, the x values look like they're at negative 1, 2, 3, 4, 5, 6, and 1. So negative 6 and 1. There we go, B. Now, if you didn't have a graphing calculator, you can still solve it. You just so if the coordinates intersect, that means that they have the same f of x values. So all you have to do is just set the two equations equal and solve. So x squared plus 7x, set that equal to 2x plus 6, and solve it. So to solve a quadratic, we know it's a quadratic because it has x squared. We need to get 0 on one side. So I'm going to 0 out this side. I'm going to subtract 2x from both sides. And I'm also going to subtract away 6 because that gives me 0 on this side. Let's see what I get here. So I get x squared. 7x minus 2x is 5x because 7 minus 2 is 5. And then I still have that minus 6 there, and I can't combine that with anything. Next, I just factor this. So I need to think of the numbers that multiply together to be negative 6 and add together to be 5. So those two numbers are going to be positive 6 and negative 1. And then I solve each individual part. X plus 6 equals 0. That means that x equals negative 6. X minus 1 equals 0. That means that x is equal to positive 1. So that's how I get my two solutions there. Excuse me. All right. Now moving on to number 9. I need some water. All right. Number 9. Given the equation 5x squared minus 4x minus 1 equals 0, find the number and type of solutions. So this is going to be based off of the discriminant. The discriminant can be found right here inside of the square root on the quadratic formula. What it does is it tells you how many solutions and what type of solutions that you're going to have when you solve the expression. One real easy way to do this is just to find the numbers that you get. Here's a real easy way to do it, just graph it. See, if I graph out the expression 5x squared minus 4x minus 1, where does it pass through the x-axis? Well, it looks like it's going to pass through at, let's see here, 1 and somewhere in between 0 and negative 1. So like you'll have one positive and one negative solution, so A would be your answer if you graph it. But if you didn't have a graphing calculator, that's okay. You use the discriminant that I was talking about, that b squared minus 4ac. That's part of the quadratic formula. And we get the a, b, and c values the same way that we got a, b, and c from the previous problem, number 5 or whatever. So our a value is equal to 5, our b value is equal to negative 4, and our c value is equal to negative 1. If I plug all that stuff in, I get negative 4 squared minus 4 times a, which is 5, times c, which is negative 1. Negative 4 squared is 16. Negative 4 times 5 times negative 1 gives me positive 20. If I add those two together, I get 36. Since this is a positive number, I'm going to end up with two real solutions. And the only one of these that has two real solutions is here, one positive and one negative real solution. So A would be my answer for that. The other options would be if this number that I calculate was negative, like if it was a negative 36, for example, then that means that I'd have two imaginary solutions or two complex solutions. And then if I had 0, magically, if it was any negative number, it'd be two complex solutions. Any positive number, it's two real solutions. And if it's exactly 0, that means that I have one real solution. So, like, to get this one, 0 real, I'd have to have one real solution. To get one negative real number, I'd have to have here. The 0 real one, like in the complex ones, those kind of work together, which is kind of a weird thing to put on there, but, whatever. All right, solve this expression. Well, here's the deal. Whenever it says to solve, one of these is the right answer. So, like, you can just plug the numbers into here, and it should be equal to negative 3 if that's your answer. Let's try the very first one. I don't know. I'm going to try to plug in just 1 and see if that works. So we plug in 1, 2 times 1 squared minus 5 times 1, negative 3. Okay, so that means 1 is one of the answers, and this is the only one that has 1 in it, so that's my solution. This is how we want you to solve it. We want you to turn this into a quadratic in standard form, so 2x and then 0 out this side, so we get 2x squared minus 5x, and then we add 3 to both sides, so plus 3 equals 0, and then factor it. So you have to multiply these two numbers together, so we want numbers that multiply together to be 6, add together to be negative 5, so that's going to be negative 6 and positive 1, so you keep the lead coefficient of 2, 2x minus 6, and 2x plus 1. And then divide out the common factors, so 2 divides out of this one, 1 divides out of that one, so we get x minus 3 and 2x plus 1, and then solve it. So you get x equals 3 on this one, and x equals negative a half on this one. And wait a minute, 3 and negative a half. So wait, why did 1 work then? And 3 halves. Did I do this wrong? No, let me see. No, that's right. Let me just double check on that one. So if I graphed it out, 2x to the second power minus 5x and then plus 3, graph. Yeah, it's just one solution, and that's it, just one. Oh, no, there'll be another one on there because 3 halves should work also. Let's just double check. 1.5, yeah, 0. Okay, so I must have just graphed this wrong or solved this incorrectly. Let's see here. 2, negative 5, positive 3. Numbers that multiply together be positive 6. Add together. Oh, that's why. Duh. I did the wrong numbers in here, didn't I? Why didn't you tell me that? I'm just kidding. I know that I can't hear what you're saying. You could say all sorts of awful things about me right now if you wanted to, and I can never hear them. Or can I? No, I can't. Okay, anyways, let's see. So the numbers that multiply together be 6, add together be negative 5. That's negative 3 and negative 2. Jeez, come on, Mr. Cook. So negative 3 there, negative 2 there. Divide out the common factor. So 1 divides out of there, 2 divides out of there. So I get 2x minus 3, and then x minus 1. Yeah, that gets my solutions. There we go. you know what? I bet one of these solutions is on there just because of that. So you got to watch out for those distractors because it might like end up, if you make a mistake, we might have accounted for that and put an answer on there. Like I made that mistake and the answer was on there. That's crazy. But anyways, so set each of these equal to 0, 2x minus 3 equals 0, and solve it. Add 3, divide by 2, you get x equals 3 halves. And then set this one equal to 0, add 1 to both sides, x equals 1. So there's my two solutions that I anticipated. And I got it right this time. Made a little detour to get there, though. But anyways, so that's the first 10 problems. Let's see here. I haven't really used the formula sheet much except for quadratic formula, so maybe that's something you definitely want to make sure that you know how to use. So that's the first 10 problems. We're moving on to the next page.